I can use the sum to product formula in order to solve this equation so that I can use the zero product property, because at this point I can't set sine of 3x equal to 0 and sine x equal to 0. I need to combine this into a product so I can then solve. And I also can't factor anything because sine of 3x and sine x are different. So let's recall the sum formula for sine x and sine y. In our equation here, we're going to let x equal 3x, and we're going to let y equals x. Then the sum of sine 3x plus sine x is going to be equal to 2 sine 3x plus x over 2 times cosine 3x minus x over 2, and that's going to be equal to 0. 3x plus x is 4x divided by 2 is 2x. 3x minus x is 2x divided by 2 is x. I then have 2 times the sine of 2x times the sine of cosine x equals 0. I can divide through by 2. Two sine x, 2x cosine x divided by 2 is sine 2x cosine x. 0 divided by 2 is 0. And now I can use the zero product property to set sine 2x equal to 0 and cosine x equal to 0. Cosine of x equals 0 happens when x equals pi over 2 and 3 pi over 2 on the interval from 0 to 2 pi. So this is x equals pi over 2 and 3 pi over 2. Whenever you have cosine x, sine x, tangent x, cotangent x, and you're using the unit circle, you can find all of the values straight from the unit circle. When we have a double angle or a half angle, you need to use your general solution to make sure you have all of the values that work. So for sine 2x, I want to find the general solution and verify that I'm getting all of the values. Because right now, if I considered sine 2x, and I thought about, well, when's sine 0? Sine is 0 at 0 and pi. This means that 2x equals 0 and 2x equals pi, or x equals 0 and pi over 2, and I would think, okay, I'm finished. But that's not the case. Let's use the general solution. That's saying that 2x equals 0 plus 2n pi, and 2x equals pi plus 2n pi. Dividing through by 2, I have x equals 0 plus n pi, and x equals pi over 2 plus n pi. So let's find all of the values from 0 to 2 pi. If n equals 0, then I get x equals 0, x equals pi over 2. We've already found those values. But what about when n equals 1? What's the next values that we get? Then we get 0 plus pi, which is pi, and we get pi over 2 plus pi, which is 3 pi over 2. What about n equals 2? That gives me 0 plus 2 pi, or 2 pi. That's larger than our interval, which means the next one's going to be larger as well. Pi over 2 plus 2 pi is 5 pi over 2. Both of these are larger than 2 pi. We ignore them, but notice that we got another value because we didn't have pi in our original solutions. We do have 3 pi over 2 already in the cosine solution, but our full solution set is 0, pi over 2, pi, 3 pi over 2. Solving the equation on the interval from 0 to 2 pi of tangent x plus 1 equals secant x.
Secant x is the same thing as 1 over cosine x.
And I don't really want to use 1 over cosine, and tangent is sine over cosine. There's not really a lot that I can do here. I can't factor, I can't use a zero product property here. I think I'm going to need to square both sides in order to be able to use some sort of identity to get similar terms or to be able to factor. Let's see what happens when I square both sides of this equation. That gives me tangent squared x plus 2 tangent x plus 1 equals secant squared x. Well, I do have some Pythagorean identities that involve tangent and secant. Tangent squared x plus 1 is equal to secant squared x. And I have tangent squared x plus 1 on the left-hand side of the equation. Let's move the secant squared to the left-hand side. I have tangent squared x plus 1 plus 2 tangent x minus secant squared x equals 0. I combined the tangent squared x plus 1 together because I'm going to replace that with secant squared x. Secant squared x plus 2 tangent x minus secant squared x equals 0. And I have 2 tangent x equals 0. Then tangent x equals 0. Okay. Well, when is the sine of x over the cosine of x equal to 0? That happens at 0 and pi. But we've squared both sides of this equation. We have got to make sure that both 0 and pi are actual solutions. Because if they're not, we could have added some extraneous solutions in by squaring both sides of the equation. Let's see what happens. Let's take the tangent of 0 plus 1 equal to the secant of 0. The tangent at 0 is equal to the sine at 0 over the cosine at 0. Sine at 0 is 0, cosine at 0 is 1, plus 1. Secant is 1 over cosine, and the cosine at 0 is 1. So this is saying 0 plus 1 equals 1, and 1 equals 1. That's true. So 0 is a solution. Let's try pi. Tangent at pi plus 1 equals secant pi. The tangent at pi is the sine over the cosine, or 0 over negative 1, plus 1. And the secant is 1 over the cosine of pi, and the cosine of pi is negative 1. This is saying 0 plus 1 possibly equals negative 1. Does 1 equal negative 1? No, it does not. So pi is not a solution. Our only solution then is 0. Solve the equation on the interval 0 to 2 pi, giving the exact solution in radians and giving an approximation in degrees rounded to one decimal place. These are not common values that you see on the unit circle. They're not your multiple of pi over 6, pi over 4, pi over 3, pi over 2, and so on. So we're going to be using our inverse functions to solve. I'm going to make sure my calculator is in degree mode first. The cosine x equals 0.6 is the same thing as the inverse cosine of 0.6 equal to x. My calculator returns a value of 53.1 degrees for this first answer. Let's think about cosine though. We're talking about from 0 to 2 pi. Cosine x is positive in the first and fourth quadrants. This is a first quadrant angle. So we need to find the reference angle that corresponds. So in the fourth quadrant, what we do is we take 360 degrees minus our angle, and we get 306.9 degrees. So the degree answers are 53.1 degrees and 306.9 degrees. For radians, we don't want an approximation, which means I don't want some decimal number. I don't want to turn my calculator into radians and do the same thing. I want to leave it as an inverse function. The radian solution then for the first quadrant is cosine inverse 0.6. And the fourth quadrant is 2 pi minus cosine inverse 0.6. And those are my solutions. I'm going to use the same approach for part B. I'm going to do the inverse tangent of negative 5 equals x in my calculator. That's going to give me a value of negative 78.7 degrees. So that's in the fourth quadrant, so negative fourth quadrant angle. The reference angle is going to be the absolute value of that. which is 78.7 degrees. So to find the fourth quadrant angle measure and the second quadrant angle measure, I'm going to do 360 degrees minus 78.7 degrees and 180 degrees minus 78.7 degrees. That's going to give me 281.3 degrees and 101.3 degrees. Same thing for radians. I'm going to, instead of saying 360 degrees, I'm going to say 2 pi. Instead of 180 degrees, I'm going to say pi. Or instead of 78.7 degrees, I'm going to say inverse tangent negative 5. So I'm going to have pi minus the inverse tangent of negative 5 and 2 pi minus the inverse tangent of negative 5. And again, just showing you that this is the reference angle that I was using. And that's your solution. For this question on Skills Practice 12, where we're going to use a graphing utility to solve an equation cosine 3x equals 0.6x, I'm actually going to use Desmos to show you that I'm trying to figure out when the cosine of 3x equals 0.6x, and I'm going to be looking for their intersection. So let's head over to Desmos now. In Desmos, what I've done is I've taken the left side of the equation and made it a y equals function, and I've taken the right side of the equation and made it a y equals function. So I have y equals the cosine of 3x and y equals 0.6x. One is a linear equation, one is a trigonometric equation. And I want to know when they intersect. I'm going to zoom in a little bit, and you can see the dots that Desmos created for me. Those are the three solutions where cosine of 3x equals 0.6x. So it's true when x equals what value. So I know I have a y value, that's the function value, but I want to know the x value. Now when I look at my graph like this, I only get 3 decimals of significance. The question asked for 4. I'm going to zoom in even more, and now I get 4 digits of significance. The x solutions then are negative 1.2792, negative 0.6591, and 0.4355. You can do this on a Texas Instruments calculator. You have to use the intersect feature, and you have to tell the graph the left side and the right side of your x values of where you think the 0 lies. It's a little bit trickier. I think Desmos is a little bit more straightforward and easier to see, and you can just touch right on the graph and the zeros show up. That's it for this section.